There'll be another presentation this evening at 5 o'clock at McIntyre, DREGS invited me to. So it's great to be back here, a little bit nostalgic, walking up through the campus, Berkeley Hall, and whatnot, and seeing some old friends, newer friends, et cetera, other people. There's about, for folks who come later, the later talk, there might be about 10 slides that go back. That's going to be talking specifically about alteration styles, but some of these introductory slides will be used later as well. But there will be sort of a different context in that. And I'm going to focus on the cap hosted from gold deposits, transition deposit porphyries, discovery histories, because they're what I've worked on and know. The case studies I'm going to present, I've been involved with. I haven't been responsible for discoveries, but I've been involved with that process. So I've given a little bit of the background. And as I say, discovery versus dogma. You can call it whatever you want, blindsided or whatever, following a model or et cetera, but we have to be broad-minded because geology is very variable, and as a result, very little falls into boxes. I would say that we learn more from our mistakes than our successes, and of course, if we learn from other people's mistakes, that's even better. So that's really the purpose here. I say mistake, but not necessarily mistakes. We, in many cases, don't know what the context was, political, social, and other, and logistic, let alone geologic. So I'm not blaming anyone. In hindsight, we say, oh, they didn't do it right. And in fact, I'm going to be naming some names, and Kroll shouldn't be taking anything personally if I say that Newmont, should have drilled deeper on this project. That was the way it was. Whereas Nate Brewer, I'm going to be waving this flag and saying that's exactly how you do it. So I didn't know these guys were going to be in the audience. So that's interesting. Okay, let's get started. And this is a target project in Archive District in Southern Peru. Top is at 5440 meters elevation. That's one reason why it was discovered. But the other reason was because it was in the middle of a vein district. Everybody knew that these are huge veins in southern Peru. Why would a gold company go explore there? So this will be one example I'll show a bit later. Okay. Just for anyone not familiar with hydrothermal deposits, let's see, okay, I guess I don't have to do anything top there. Okay, location, metallurgy, hills, and convergent margins. That's basically what we're looking at. Epithermal, less than a kilometer, porphyry, typically less than 2 to 3 kilometers depth. And we have, of course, the Miocene, tertiary, Miocene, Pliocene, circle of fire, Pacific, volcanic belt, and of course, at least overlapping in space are a variety of porphyry and epithermal deposits. The older Cretaceous to Eocene through even younger ethnic belt from Southeast Asia to Western Europe, Northern Africa, Paleozoic belts in Mongolia, into Central Asia, also Eastern Australia, Eastern US. There are Neoproterozoic epithermal deposits looking exactly like the million-year-old McLaughlin in California. Same with Aldab in Saudi Arabia, Neoproterozoic, through to Paleoproterozoic, metamorphosed, but nevertheless epithermal deposits. So the apparent decline with time is simply a factor of erosion and preservation. You could be in old rocks and still have epithermal potential. There are some arguments over whether some deposits are orogenic or metamorphosed epithermal in Canada. And I don't go there because I've never really worked in Canada, and also my wife works on those, and we don't discuss geology over the dinner table. Okay, I don't have to tell you, I was telling some undergraduate students a couple of days ago, but I don't have to tell you that there are a lot of critical metals in porphyry systems. 70% at least the world gold, copper, 50% of moly, most rhenium, indium. Indium is used for. Thank you. Yeah. Actually, two people knew it at the previous lecture I gave that they knew what indium was used for. Prior to that, I never had anyone say it's in everyone's pocket. Unbelievable. My geology students. A lot of gold, silver, more silver than gold, variety of elements. So as I said, I don't have to tell you that. But outline, we're going to talk about magnetic epithelial systems, active ones particularly, as an introduction. Then several examples, case studies of discovery examples of epithelial deposits, and a little bit of porphyry. I think I turned off some slides. I could turn back on depending on the time available. And many have been found after 2 to 4 earlier companies. So, of course, geological observation, everybody's done their own amount of geological observation. I'm not going to have any magic bullets for exploration, no magic tools or techniques, just good geology, which means good geologists to start with. And particularly, another bottom line, don't force prospect into a model. I've seen that a lot of times. Models even that I've published. I say, don't use them, Learn about them, the concepts, but then go out and see the field. And of course, more and more experience you have, the better off you are in interpreting it. A bit of history. Vic Shilto published this paper in about 2 years, 4 sets of reviewers from economic geology, most of them from Southwest US. You can imagine who they were. If you've read the literature those days, talked about the porphyry ore deposit, tops, volcanoes. In this case, Vic was flying from Antofagasta to Santiago. At the end of the day, sitting on the left side, the sunset was coming in, illuminating these young volcanoes, some of which were sector collapse, and exposing the type of alteration that he was working on in more deeply eroded porphyries. Penny dropped, he wrote the paper, and time was accepted. Now, there's some variations I'll show you in a moment, but basically, that's the concept. And he said that the large amounts of sulfur, the fumarole, are the excellent products of actively forming porphyry copper systems. Very prescient. And of course, it was that those sector collapses exposing this shallow advanced alteration, which I'll be talking about this evening, which gave him that clue. Well, a volcano has been in the news recently, 2019, unfortunate hydrothermal eruptions when tourists were out here, unfortunate deaths and injury here. Don't underestimate active volcanoes, any active hydrothermal system. High temperature vapors, 90% water, but with a variety of other volatiles, including SO2 and HCl, acidic gases, which we'll discuss in a moment. This is quite a eruption. And notice those fumaroles, one here and one there, and a subsequent image I'll be taking a photograph here. A high temperature. And I could have set this up so you just click on that and it goes, but I'm just like my folks, so I just come down here and start it.
You're standing there to watch a sample.
You have to know what you're doing, you have to know what your colleagues are doing, because it's noisy. These are low temperature fumaroles, 300 degrees or so, not the really high temperature ones. And here we are looking now down on the ground, field assisting for Werner Degenbach. At that time, the best. the most famous volcanic gas caverns in the world, in Germany. And these minerals through here, well, for some reason, I can see that. Yeah, just click, okay. These are now steam heated. We call these steam heated 100-degree vapors. These vapors have only CO2 and H2S because the reactive volatiles have those that are condensed in the hydrogen system, react with the rock, they're reduced, and you just have the CO2 and H2S left, rises to the surface above the groundwater table into the vapor zone. You get atmospheric oxygen, oxidizes the H2S to the same H2SO4, but lower concentrations, so pHs are 2 to 3 versus the pHs of 1 in these hydrogen kind of things. They form an alkaline alteration in the hydrogen sense, and they claim that alkaline alteration also in these blankets. And if you simply send samples off for short-wave thread analysis, comes back alkaline, you don't know. Well, you might feel that you prefer one over the other, but basically, unless you have textures, occurrences, morphology, you don't know where to interpret. That would be, in fact, the topic of this afternoon's, this evening's talk. And these are not boiling springs. This is simply that's CO2 and resin coming through. The H2S is oxidizing, CO2 comes through. CO2 is 10 to 20 times more than H2S. H2S oxidizes, so CO2 has to go. This afternoon, we're going to come back to the CO2. It's really important for forming argillic alteration, clay alteration on the margins of systems. So that's where to silicose to the diagram. In everything involved, including the intrusions, porphyrin-related deeper deposits, shallow alteration, shallow mineralization. And just to give you an idea, here we have intrusion at depth. It dissolves a critical behavior fluid that is high salinity, low salinity, single phase inclusion, 5% or so. And you can see compared daughter minerals here, up to 1.2% copper in solution. That is the parent copper fluid. But it, as it ascends, it intersects with solvents. Some people call it boiling. I don't like that term for this process because we end up going from 5 to 51% salinity by separating roughly 90% of the liquid, extracting 90% of the liquid as vapor. The brine, of course, is dense, stays at depth, forms this early alteration, whereas the vapor is buoyant and rises to discharge or passively begets the volcanoes. We might have other low temperature steam heated features at the surface. And so when this was all appreciated, suddenly you realize that formation of these lithocaps of hydrogen advanced argillic alteration from these magnetic vapor condensates they're coupled with the brine. They require that there is a brine at depth and a shallow intrusion. Maybe it's not a porphyry or deposit or even a mineralized deposit, but there is a intrusion in hydrogen system at depth. And the hydrogen alteration, 1995, Silicon coined the term lithocap, advanced argillic alteration. Again, I'll discuss this more implication for exploration this evening. The epithermal part of the picture here, Valdemar Lindgren find it in 1922. Epi is Greek for over above, and he recognized that this was a very shallow environment. He said 3,000 feet, basically a kilometer. It's not a sharp line. It could be shallower or deeper depending on processes. But And then there was a transition. He didn't appreciate transition, but silica did to the topsoil porphyries. And again, that'll be a topic this evening. Here, Satsuma, just south of Kyushu. We worked here along with Mary Mubach in 1991, and very, very accessible. There's an 800-year-old fishing village right around the corner. If you want fresh fish, go there. Nothing fresh, it just comes in off the dock and goes to your table. And in that whole time, they had not witnessed any eruptions from this 1,000-year Raleigh dome. It had just been degassing. Again, high temperature vapors up to 880 degrees, with maximum 1 to 2 part per trillion gold. Do the math. We know the flux of this. You transport kilograms of gold in 1,000 years, not tons and tons. So this is basically not, and 1 to 2 ppm copper, up to 10 ppm copper. So this is not an ore-bearing vapor, despite what some academics suggest in print. Here, Bernard is looking at this rhyolite. He's a fluid chemist, but he's looking at imagining the fluid reactions that took this rhyolite, 71% silica, converted it to a 97% silica rock. Obviously, you have to leach all cations, including aluminum. And Roger Sufferman showed experimentally that for aluminum to leach, you need a pH less than about 2. And so this was pH less than 2. And where does it go? This is isochemically dissolved rhyolite. Isochemical except for silica. Silica in solution is silicic acid. Doesn't matter if pH is 7 or pH 0, the solubility of silicic acid is the same relative to pH, essentially. So the silica stays in the rock. Otherwise, you end up leaching big hole in it. And that silica forms residual silica siliceous material, which recrystallizes quartz, and the texture reflects the original texture of the rock. Again, something to discuss later today. That's the two disproportionately, sulfuric acid and H2S, along with HCl, these are the acid species. And if you remember back to your high school chemistry, high temperature acids, they're associated. They're not reactive. At 300 degrees, if you didn't burn yourself, you could put your hand in the 300-degree 1 mol sulfuric acid, and you wouldn't burn your hand in terms of acidity. The equilibrium constant decreases by a factor of 50 to 200 degrees. So you suddenly have really reactive fluids at 200 degrees. And because of that, the cooling during ascent and interactivity means you have this shape of alteration tail. Some people used to say that that was steam heated waters coming down along structures and being neutralized with the rock and pitching downwards. It's exactly the opposite. It's flaring upwards. And tonight, we might have a slide or two later here. So chrysolite here, up to 97% silica, alunite, some clays, all the samples less than 2 ppb gold. Detection limit, 1 sample 29 ppb gold, but that was an efflorescent deposit right next to the fumarole. Okay, Satsuma Raleigh erupted 1,000 years ago, hydrothermal system, very acidic alteration. And we go onshore, straight 30 kilometers to the north, and we're at Iwako, 4 million year alunite in this quartz alunite alteration. And from the pit, you can't see the oceans. So this is why I took the photograph right here. And the pit is here. All residual quartz, all the pyrite and sulfur salts have been oxidized. So this is all the residual quartz. I'll show you the compact of alteration in the next slide. And average grade, this is about 3 grams. This is not a gold deposit. This is a silica flux quarry with byproduct gold. All of this silica flux goes to Sumitomo smelter, and the gold credit pays for the transport and more. So Professor Hiroshima standing right on that contact, knife sharp. And of course, here you can see where the feeder zone is flaring up to the peripheral horizon, and below is dicite. There's also some profiling here between the residual quartz and quartz alunite. In plan, it almost looks like this is one elongated body, 900 meters long, with pods of greater than 1 gram gold. But in cross section, you can see that at the andesite, there were fractures cutting through the andesite, fluids are rising along, and then when they hit this unwelded tooth, they spread out, they mushroom. Professor Hiroshima said hongo, described it as hongo, which is Japanese for mushroom, and this was literally the first recognition of lithocap control, lithology control on a silicic body, but always where mineralized, the highest grades are in the feeders. And that's something to realize, that if you're sampling on the margin of a lithocap, you have to define the feeder. You don't define the feeder, you can't kill a project. If you do define a feeder or feeders and it's low grade, well, then more comfortable to kill a project. Okay. This is closer to home here, something about Colorado. It was snowing that day. We went up with the group. So the economic geologists are standing on top of the residuals of quartz ore host, and the alteration geologists are standing on the quartz alunite zone here. Nice contrast, which you have to imagine is there because you can't see it. And yeah, this is technicality of the term buggy silica. Now, we don't like silica because silica is a species, not a mineral. So we say quartz, or the original, it was amorphous silica residue. And also buggy. Buggy is reflecting the original texture of the rock. I've done projects, people say, we don't have any buggy quartz here. You go to the first outcrop and hit it, and ping, you know, your hammer bounces back. It's massive silicic rock. Either it was microcrystalline, so it doesn't develop a buggy texture, or it the bugs were filled by subsequent silicification. And on the margin, quartz alunite. This was a monzonite with 2 centimeter size crystal. So prefer to use the term buggy for as a descriptor, with residual quartz with buggy texture after finicris, fine finicris, coarse finicris, after pumice, after welded pumice, etc., etc. And Simarate in 1960, the study, it was still being mined right up to this time, I think, underground. And so they had access to underground. They recognized that these zones were flaring upwards. And we now know why. The fluids are simply cooling. They also noted that tentite calcare depth converted to nargite copelite upwards. And in both cases, the upward flaring is related to dissociation of acids and becoming more active on cooling, and the shift from intermediate to high sulfation state sulfides is simply due to cooling, which I think I often leave that out. Okay, I might have it, I'm not sure. I usually don't want to throw a phase diagram out, but sometimes I do. Okay, there's residual quartz ore along the structure, cutting this monzonite dome with symmetric halos of quartz alunite. And if we look at, say, roughly through here, that is the contact between quartz alunite alteration, residual quartz, buggy texture after these finicris, and based on Roger Software's work, aluminum hydroxides become soluble at a pH of 2. Roughly, you can put your hand on that pH 2 contour here. I've gone to a project, particularly in Australia, where they had faults everywhere there was a sharp contact. I said, why faults? Oh, it's such a sharp alteration contact. There must be a fault. I said, no, and showed them some of these examples. So again, Simarate mineralized residual quartz, because this is the conduit subsequently mineralized with alunite kaolinite. Because, oops, sorry. Yeah, there's a phase diagram. Because alunite kaolinite is stable pH 2 to 4. With clay, stable 4 to 6, illite out to lower temperature monomer illite to chlorite, and feldspars propylitic style because pH is greater than 6. It's simply almost a chromatographic column of acid alteration out to fresh rock. Now, that can be 10 meters wide, as in this case, or this inner zone can be hundreds of meters wide, as Len will know from Yanacocha. And of course, this deposit was less than 1 million ounces. Yanacocha, what? 40 million ounces. Times. And very briefly, sulfidation state. Our magmas have this pathway of cooling through boron magnetite, low sulfidation state solubility, through the tops of porphyries into intermediate sulfidation state. And because of the rock buffer with iron 2,3 and silicates, as defined by DREGS, oftentimes fluids stay in intermediate sulfidation stability. They're being pulled back to the rock buffer. Tentite, pyrite, etc. However, what happens if we don't have a rock buffer? Where might we not have a rock buffer? Possibly where we've dissolved the rock and leached it, so 97% silica. Or it might be quartzite or big quartz veins, or even micro plus porphyry. That's how we don't have the iron rock buffer there. And as a result, those fluids enter inargestably or coldly on cooling. I don't think it's rocket science. This is a very simple diagram for understanding these relationships. Of course, there's heating and cooling back and forth. Perigenically, it's not this simple all the time. With magmas, more reduced, lower sulfidation state, fluids rising from greater depths along the rock buffer. Surprise, surprise, in Nevada, they end up with arsopyrite pyrrhotite stability, low sulfide content. They're low sulfidation deposits, and those deposits are reflecting the nature of the magmas, just as these deposits are reflecting the more oxidized and high sulfidation state of those magmas. But that's not the purpose of the talk. We have lithogaps, thermal lithologic horizon, with core residual quartz, halos, quartz, alite, expanding upward, barren formation, vapor zone transport metals. There's always, lithogaps always have feeders, but not all feeders have lithogaps, like in the case of Summitville. This monazite dome didn't have any lithologic permeability, so fluids only rose along the fractures. The old timers mined underground 10 grams average grade. Friedland went in to try and open pit mine, and basically he only got as much out at an average grade of less than a gram per ton, and it just didn't support that kind of mining operation. And, well, these are the rock types, residual quartz, porcellite. We already mentioned steam-heated alteration. Friable, we'll come back to this steam-heated alteration a little bit later, for example. And where mineralized, best grades are in the feeder zone. But sometimes they're not mineralized. And that's, you have to know when to stop drilling. Nate, how many barren lithogaps have you drilled until you said, oh, we have to stop?
Probably 30 or 40.
And how many have you drilled that were mineralized?
10% of that.
And how many are in mines right now? At least one that I know.
There should be a second one, yeah.
Okay, good. Okay, good. Okay. Discovered just by dogma, yeah. Well, many deposits discovered by subsequent companies after the first groups failed. Why? And some deposits discovered by the first company. I'll go back to Nate again. And that question is how. I'll certainly give you the how example, really good example. Mulattoes, in Mexico, buggy quartz is steep. I was working with Plastic Dome group, developing criteria, and that was one of the first things that, and it must be sampled, because it is, if it's mineralized, this is the core of mineralization, not the marginal quartz granite, etc. Here is Sasal. At least 4 groups came in. Sasal Sasal is in Chihuahua. Mulattoes across the border in Sonora. 4 groups came in. very hot, coming through here, look up, difficult, dangerous, hot. Let's just collect some samples here, go back home. Elaine Charest, a French Canadian mountain climber, came in here and said, you know, I haven't done anything else today, but at least I'm going to climb this slope. And he collected samples as he went, and I'll show you his results in a moment. They come in by the Hedenquist River. These are 500-meter grids. Walk through clay alteration on the margin into not quartz alunite, do a bit of alunite, mainly quartz dickite. Residual quartz zones, that's the steep part. Here's a section. It's covered by post-middle cover, 25-million-year-old Sierra Madre volcanics, pyroclastics. And if you collect the samples of the quartz dickite alunite, whether or not it was sulfide bearing or oxidized down here, everything would have been less than 1 gram. And if you went up that face in the residual quartz, you would have been collecting up to 2 and greater than 2 grams gold. Even if you'd been standing on the top of this quartz alunite, you wouldn't have gotten high grades. Of course, this was subsequently tilted 30 degrees based on range faulting. So that is actually a horizontal lithocap. We turn it back, and these dikes are near vertical, and those feeder zones are near vertical. Okay, so that's just a little bit of background, well, introduction and background. These are lithocaps in South America. Not continuous lithocaps, but those belts have abundant lithocaps. And here in central Chile, we have other areas with a variety of high sulfidation gold deposits and or porphyry gold deposits labeled in through here. The examples I'm going to present will be El Indio, where I first met Nate a few years ago, I think, and Pascual. Then to Yanacocha, Quimswicha, now Loma Larga in Ecuador, and La Coipa, and Flores Norte. Sort of, some of these are a bit pairs. Oh, also Argentani, Candiwiri. That was another goldfields discovery. That's right, yeah. So, you must have known I was going to be presenting all of this stuff here. Hope you're keeping me honest here if I make any mistakes. This photograph is probably taken, this is probably your vehicle, Nate.
Yeah, that's my point.
Yeah. I was here previously, 10 years earlier, but we went up and drove through this area. El Indio. It is, there was some Petroneros mining material in the lithium and talus, but the famous high-grade veins were not discovered at the surface. A little bit of surface mining, but most of the mining underground and at 40-50 meters elevation. And it's particularly famous because of the direct shipping port, 200 grams average grade, cut off 100 grams, 45 tons of total 40 tons gold produced. In what, the first 2 years, this was before your time, but very quickly they produced.
Yeah, they paid back the capital before they opened the mill.
Not bad. And the underground miners, the miner didn't recognize when they had drifted across this structure containing this material because it's a gold copper amalgam and doesn't exactly look like gold. But this sample that Randy Janus gave to me, and I used to use in teaching collections, and somebody walked off with it in their pocket. It was, he said, probably 5 to 10 kilograms.
They call it oro chileno.
Good. Yeah. No, it was fantastic. This is before I knew what creamy silica was. We'll come back to that. Well, maybe a little bit later. This is not, it's called quartz pyrite gold veins, but this was not quartz when precipitated. It's clearly, it was precipitated as a colloidal silicon gel, sort of chalcedonic now. Okay. Steaming alteration, high grade ore body, 350 meters below the top. St. Joe had this land. I think it was St. Joe that was first working up here. Was it St. Joe that put the adit in?
No, that was the
or
That
angle.
was farmed out to somebody else, I've forgotten now.
Right.
Yeah.
And so they said El Indio, high grade 350 meters below the top surface. Maybe or maybe not, they didn't recognize that seeming alteration. And so they put in an adit 4 meters long, and they didn't get anything. Actually, the end was pretty close to some grade, but they didn't go far enough. And so it was dropped back and forth. And then Raymond Janis came along. He had been, my first visit in 85, he had been a mine geologist at El Indio. He came up here, and this is a steaming alteration. And although usually I say steaming alteration is barren, but he trenched this, and before Barrick had taken over the company, taken over what? Lack or Bond? Lack, thank you. My memory's in the audience. He'd outlined 2 million ounces of gold. This here, very close to the surface, in steaming alteration, that in fact had overprinted because of falling relative, but that's no story. Eric John said, well, you know, kind of small, but we'll just continue exploring. Well, that became what, a 40 million ounce deposit that may or may not be mined, it's probably not surface. They might mine it underground for higher rates. But this was dogma to start with. Raymond came in and said, well, let's just start sampling. Let's do the geology, start sampling. That was the discovery of then, the resource was about 450 tons of gold, 15 million ounces. Steaming alteration, supergene alteration through here, and a Chenard's cross section. This is the residual quartz. It's actually hosted by intrusions. And you can see the grades here up to 4 grams in darker color, with up to a 200 meter thick quartz kaolite steaming and alteration blanket, but then the groundwater table was falling with time due to sedimentary erosion, and that resulted in steaming alteration coming down, penetrating down along the structure. So basically, because someone went in and said, let's just start with, you know, doing the geology and sampling the rocks. Okay, this is a view over at Carachugo to Chaquicocha Dome. I'm going to talk more about this afternoon. Oops, sorry. I didn't put in another slide here, perhaps this evening's slide. I'm not going to go into it. I'm already certainly running over time. Residual quartz in a lithocap after the San Jose pyroclastic units. Welded, but they were so welded, they were so brittle that they fractured nicely. So they were a printable host. And we see the quartzite through here. This is all oxidized. Quartzite, brownish, and there's still pyrite in this rock, in the clays. And until the mid-90s, all known gold deposits, outcrop at greater than half gram gold phenomenon. And the next slide, I'll show that Tony Longo was working here on Chaquicocha, and he saw a lot of barren silica granular that was interpreted as steaming alteration, but there's no way because it's 100% silica. It's actually quartz allanite pyrite, where the pyrite has supergene oxidized, dissolved allanite, left with this standing material. But it's all barren, locally some gold. And he argued, based on the breccia textures here and the alteration, that there should be a deposit at depth. And he was told, no, all the deposits outcrop with grade. Why are you drilling barren rock? Well, okay, sorry, this is where I put the slide. This is on the margin of this Bayside dome. We see that this is a finely laminated siliceous deposit, no replacement textures, no plastic material, and it's cross-threaded. This is siliceous material is precipitated from colloidal silica in a, not precipitated, deposited from colloidal silica in a Ascrated Lake. So we know that that was paleosurface. This is probably 1,500 meters below paleosurface. And the next slide showed the eventual discovery of Sarachek Kocha, some shallow grades, but basically the top mineralization, 200 meters, the highest grade deposit known, still sitting there for underground mining, but average grade of 5 grams per ton. And Tony kept pushing. Finally, probably shut him up. I don't know. They drilled it, and it was a nice discovery. So that also was a bit of a dogma. Okay, all of our deposits, known deposits, outcrop with grade. Is that always the case? Whether or not there's been any type of faulting or other control on vertical level. Newmont came to southern Ecuador well, I've got the slide here in a moment, but some were calling this Yanacocha Norte because they saw this large area of residual quartz along the ribs, structural ribs, quartz alunite, etc. Not very good grades at the surface, up to half gram anomalies, etc. In retrospect, when I first went here, down to 30, this is 3,800 meters, down to 3,600 meters, 37-meter wide, larger quartz vein with 10 grams gold. Okay, that's nice, but up here, half gram gold and residual quartz. Newmont JP with Gemma in 1993 eventually drilled 8,000 meters, average 82 holes, averaged about 93 meters. And the reason being was, from what I've been told, it was a business model that interested in something like Yanacocha, which is shallow, something that could be open pit mined, heap leached, etc. And that's why they were drilling shallow holes. No deeper, not gonna underground mine this area. But one of the holes intersected 2 meters for 83 grams. And Richard Spencer with I'm Gold, the Ecuador manager for I'm Gold, is a structural geologist. He said, that looks to me like it must be a structure control. So after developing the JV, a couple of years getting drill permits, they drilled, well, starting at the end of 2002, 6 campaigns of drilling. And the last campaign, the 40th hole, on top of 82 earlier holes, but 40th hole, these being an average of 330 meters depth, 100 meters and 9.5 grams, drilled into the feeder zone. Here's the Newmont map, still of geology. You can see a 4-kilometer cross cauldron, an early diatreme breccia with class of porphyry material, with class assay 0.2% copper, and then subsequent intrusion by dacite domes through here. You can see the structures, regional structures that have been inherited through the young volcanic rocks, north-south, northeast, southwest. And andesite flows that are basically flowing out radial from this area. If we look at, again, Newmont mapping, the alteration, you see residual quartz alunite. Sorry, the blues are the residual quartz, purples are quartz alunite. The eventual discovery of Kansikochi was here with almost no surface mapping. It was a small, low-grade resource defined here by Newmont, but then they left because it just wasn't what they were looking for. Okay. This is a very instructive cross-section from Iron Gold. This is what Newmont was testing, and you can see the residual quartz, the silicified zone, is following the paleotubes. And there are 2 horizons, andesitic lava flows and the paleotubes in between, permeable versus aquatards of these andesite flows. I mean, if somebody asked me before this experience, can you have multiple lithocaps? I said, well, maybe, but probably not that likely. But these are stacked lithocaps. One question is, where's the feeder? Because I'm Gold and drilling this. They knew they had 30 meters or 2 grams here and there, but where's the feeder? Here's that leached and solidified, unwelded pump stove horizon depth. Well, one of the things they're doing a lot of things, good lithology, structural work, etc., but also doing clay alteration. And we know that kelmite are lower temperature minerals than perovskite forming at about 250 degrees. And here we have directly from residual quartz to quartz kelmite to spectite alteration with what? A little bit of copper and 1 or 2 grams of gold. This hole here intersects with hanging wall of perovskite dickite, footwall just into kelmite. And this hole 103 intersected perovskite and dickite, both hanging footwalls. Also a little bit better grades, so what, 4 grams of gold, 3% copper. Well, no brainer, except that the discovery hole was 122, still 20 holes after that. And that's the feeder zone. Remember? Highest grades are always in feeder zones. And so this is a long section, and originally 3.3 million ounces, but at a 100 ounce cutoff, now 2.2 million ounces. And remember that 3,600 meter elevation quartz vein with an argite, 10 grams gold down in the Rocky Valley? With hindsight, that was important. That was a hydrologic level of mineralization. And this was a barren lithocap, vapor condensing, but not metals getting up to that level subsequently. So learn from these mistakes. Of course, you could possibly drill deeper and get into nothing, but you have to know what is the stratigraphy here. Are there possible other terminal horizons at greater depths? So, Hedenquist in the north, Karina, these were discovered mid-80s by Newmont, 1993 first production. Karina, 1996, went into production, Barrick bought it in 1998. Fast forward to 2000, and Barrick discovered Alta Chicama here in sediments. But in 1996, after this discovery, Guido del Castillo with Arantani drillers, largest drillers with the Canadian group, I forget right now. But he asked his chief geologist, because they're also small miners, he said, what about our small base-metal silver mines down here? Why can't we have a deposit like this? So he sent his chief geologist down here, and of course, the reason that no one else was here exploring for gold was because this is a well-known silver district. Barrick actually had collected 4,000 samples in here before they bought Karina. But dare I say, they didn't know what they were looking for. You know, they didn't know the types of deposits that potentially, they had organic deposits. They didn't have this style deposit before. Karina was the first. But then they did find Alta Chicama based on knowledge of Karina. So small deposit discovered in 1997, went into production in 2002, and the cash from there, but then the larger deposit discovered in 2000 to be brought into production in 2004. And that brought Goldfields back in, well, or at least Goldfields was interested in the area, and Goldfields and others such as Buenaventura, and they had a joint venture in this area. And again, it would have been at least had knowledge of this, if not directly involved. I don't know exactly the status of that fact. And now, Southern Peru, known as the Silver Region, there are now 300 tons of gold production in the last 20 years in 5 departments in Southern Peru. And this is that first photograph. This was the presentation we made in 2004 in Perth. The story of a new ore type, lithocap hosted in an abandoned lead, zinc, silver, intermediate sulfidation vein mining district. If you remember Silito's schematic diagram. So here's the deposit. First 6 months of production was from fluvium. They just broke it up and put on a leaf pad and 1.5 grams of gold. The whole deposit was 0 strip. And Barrick and other companies that would have been in the area didn't appreciate one aspect, and that was that this is not the erosive volcanic rocks, this is a later intrusion. I'll show first this is the erosive volcanics through here, and we're subsequently intruded by this dacite dome. And that's what's bringing the alteration of mineralization, as you can see in the overprint. We have residual quartz, some massive quartz through here, and the cutoff is basically 0.25 grams. They went down to 0.18 grams at higher gold production or gold price, and basically right at the contact of the residual quartz with quartz alumine. And so this led to interest in the region, particularly by other groups. And here we're right at the base of the deposit. Actually, at about 200 meters depth, went through Apache silica, which we'll talk about tonight. Apache silica, which is porphyritic replacement of the lithocap. There's a porphyry at depth there, hasn't been drilled yet. So this is where Nate can guide me if I say, please, if I say anything wrong out of place. But Goldfields and Buenaventura joint ventured into this area, and also Goldfields had their own land, but they started looking at Chuquipaca in this area. And Chuquipaca is a quartz granite, locally residual quartz, altered dacite dome. Mostly grades are about 0.5 gram, as I recall. And through here, there were about 12 holes drilled.
Yeah, 11 holes, and they never cracked the ground.
Yeah, I remember the best grade was maybe 10, 15 meters of 0.5, 0.8 grams. So that was it. And the decision was made, well, we gave this a good shot, maybe a low grade, not barren, but low grade lithocap. But at the same time, they had some district-wide sampling. They decided to joint venture this with, well, to pass this to the joint venture partner, Buenaventura, that had a lot of dome-related base metal zinc mineralization in sediments on the margins of domes in central Peru. So Buenaventura was interested to drill these sediments, particularly where there was signs of alteration or zinc mineralization. And even though, from what I understand, the best grade of 1.1 gram gold anomaly came from over this area, the decision made to pass it to the joint venture partner. Buenaventura drilled 5 holes.
6.
Drilled 5 holes. No zinc, no gold. And my understanding is they had scheduled a meeting with Goldfield, but then discuss the end of that campaign. But then the 6th and last hole, exactly the 5th started, but the results came back after. No zinc, but 152 grams, 100 grams.
3 grams. But Cesar showed me the results of the first 5 holes at the gold forum downtown.
Yep.
He said, I'm going to turn this back to you guys, but we're still waiting on assays from the last.
From the horse's mouth. This is what I heard through, I think, maybe Chico or someone else. And, well, happens to everything, but this is called a gossip. It's not a gossip. Gossip defined as oxidation of sulfide, right? This is oxidation of anchorite.
It's a pseudo-gossip.
That's a pseudo-gossip. Because it's oxidation of iron in the rock, but as an iron carbonate. Iron carbonate is common with intermediate sulfidation systems. And here, 3-4 kilometers on the margin, intermediate sulfidation, mineralization. And now called San Gabriel, passed from back from after drill out, passed back to Buenaventura. So Buenaventura drilled the discovery hole in September 2008. Goldfields backed in, and by mid 2011 had a 230-ton gold equivalent resource. And we don't want to necessarily go into all the discussions for why Goldfields finally decided not to continue. I know that there were social problems, but also metallurgical problems, and it's still not in
It'll be in
development.
production at the end of this year.
Really? So, okay. So
Underground.
I hadn't kept up with that. Thank you again. So, again, you know, even if you're in an intrusion-centered system, and this is not looking very good, at least in the upper few hundred meters, look always within 3, 4, 5 kilometers for any signs of marginal veins, etc., which is what continuity is, except the continuity is actually structures into these sediments around a diatreme. These are juvenile textures. And it's a muddy diatreme, so it's not very permeable. But the margins of the diatreme, from what I understand, having looked at some core, is where the mineralization is hosted. So, you know, it's overall a great discovery. Moving on. Then probably will be my last example. The Quaker in silver gold deposit, production of 200 ton gold equivalent in central Chile. Dayside domes, 20 to 24 million years old. This is a quartz altar. The sulfides here is fusion oxidized. Here is residual quartz ore. You can see the Hedenquist leached out through here with sulfides. This is below the superficial oxidation zone. Late native sulfur. This is the silver gold ore. But that was laterally on Machoco. But Quaker Norte was covered by this white porous rock, opal elinite, kelnite, steam heated alteration. It's friable. It's not massive silicic through here. It has opal at the base. And with that knowledge, Placidome, well, earlier Codelco, but then eventually Placidome, look at this area here, Corinne. Sorry, back up a little bit. Quaker Norte was covered by this blanket of barren, essentially non-mineralized steam alteration, but very well developed residual quartz, mineralized residual quartz below. And we now know from White Island, you can get the steam heated alteration just cheek to jowl or right adjacent to hypogene vapors. So you should be looking for both styles of mineralization potentially, although this will be easily eroded. You take off the upper 100 meters or so. Oh, there's red, all steam heated alteration. Codelco drilled, as I recall, 11 holes, possibly with Placidome into here, steam alteration, opaline silicification through here, geochemical, geophysical exploration through here, and then to Corinne North target, and below 20, 30 meters of steam alteration, they discovered the Corinne ore body, greater than 65, like La Cueca, very high silver gold ratio, 1.5 million ounces of gold equivalent, but less than 3 grams of silver, which is not much in the steam alteration here. But this is quartz alteration with an inlight halo. This is not residual quartz like La Cueca. This is intermediate sulfidation deposit 5 kilometers away on the margins, same age. And so here again, we see that blanket, 20, 30 meter thick kelnite, remnant opal horizons. Typically, this opal is forming at less than 100 degrees, silicification along the paleo groundwater table. Well, I brought Chico Zelo and his team, who worked with Nate, here in about 2007, 8. Can't remember exactly the timing. Yeah, okay.
It's not right, 2006 or 7.
Yeah, standing on the edge of this pit and looking at everything, and they were taking notes mentally. Whatever. Fortunately, I had a close colleague, Antonio Rivas, who was the exploration manager for Placidome, South America, and that's why I managed to get a Cook's tour of this area for Goldfields Geos. Goldfields has a large area to the northeast. Won't go into the history, it's published. But they looked at, they had 10 anomalies, Aster, etc. They focused on 4. The first 3 were easier to get to. Hedenquist was drilled, and a small resource identified, I believe there. There was mineralization at one of these, at least Piedra Prada. but just wouldn't go anywhere, but they sort of had a feeling for what the alteration was like here. And finally got up to Solaris Norte at 4,400 meters. There was minor previous exploration, open ground, few roads, hard to get to. That's good for exploration in terms of not a lot of earlier people, but it is a challenge. A short exploration period, focusing on spectral anomalies that Alvaro Crosta worked on, and one of the world experts on interpretation and follow-up for targets with last being Solaris Norte. And here's Alvaro's Aster along with Landsat. Aster doesn't pick up opal. This is opaline material, this dacite dome with allied candlelight and opaline material. You could hear just like we're seeing at McQuaker, red. And this is Nate's slide. This is Nate's presentation. Allow me to use it publicly. Steam and alteration margin of this dome. That's eventual resource, early resource. That's how 7 million tons of 4 grams gold. And here we see steam and alteration right on the margin of the dome. And in this area is a diatreme with the juvenile mass. Thanks for coming. I'm sorry for not finishing on time. Couple more minutes. Soils, health spines, less than 24 ppb, rock chips, less than 35 ppb, but gold fields weren't necessarily, I don't know if they put out by this because they knew that semen alteration doesn't carry anomalies, typically. If there's an anomaly, that's great. And that was on his target, the diatreme, which was drilled by 2 RC holes. First one failed, second hole went through
96 meters, 1.5.
Thanks, at 190 meters depth. Basically the base of the steam alteration zone. And then got a core ring in, and the rest is history. Simple, right? But a lot of this afternoon, later, I'll talk about advanced circular alteration. We've written on paper, we suggest there are 5 environments for advanced circular alteration. For example, there's hydrogen. So recognize that associated with diatreme. And that's the hybrid. This is one hole that shallow creamy silica, like the material at El Indio, 50 ppb gold. But this creamy silica, colloidal silica deposition, cementing this breccia, really positive feature. 100 meters deeper, 960 grams gold. And Nate, I may have taken this slide from you, or it may have been mine. I can't remember which. But I remember we didn't have assays for this hole when I first visited. And Nate had a big smile on his face when he told me the results. And seam-hidden alteration. Seam-hidden alteration here, shallow depths, including calcitic silica, just defining paleo water table, probably multiple levels. And then limit of oxygen oxidation, another advanced circular alteration. So 3 styles. So know the environment. They all have different spatial genetic relationships with potential work. So not only know mineralogy interpreted, but also report the textures and morphology. They all tell you that environment. So it's a great discovery in history. It was based on knowing what you're looking for. Yeah, maybe there's some fortunate twists and turns here and there. You had the fortunate opportunity to visit Perenn, which basically said, don't worry if there's no grade in the surface, seeing an alteration. Oh, yeah, I skipped a few slides. One here from Newmont. Newmont geologists came to Saracotinas, 10 kilometers east of Yanacocha, and this is what they mineralized, and so they sampled this course, and this got nothing above 100 ppb. Gold came back, and they left, but there was a gold anomaly in this stream, and not Kojima, but the Peruvian state mining company, joint venture with BRGM, they came in with mules, stopped about here, and they had a patch of contact. a student who hadn't gotten finished his thesis yet, and he had all kinds of energy. He started running around the swamps here, and he saw some subcrop. He pulled back the soils, he saw this, didn't know what it was, broke off a sample, brought it back to the senior geo, and he said that those are sheeted porphyry veins. That was the simple discovery of parole. 640 million tons, 0.3 copper, 0.7 gold, sediment, sorry, was the state exploration company. Sarcoptenes, adamite, 16.06, orthoclase, 15.08, with air bars, these overlap. And probably, possibly, this is a lithocap related to this porphyry. And it's on the margins rather than directly over, because fluids in the shallow environment, there's hydraulic gradients flowing laterally, and also at lower temperatures, that's where the greatest alteration takes place. This afternoon, I'll have probably other slides on that. So, in this case, and definitely in Ancocha, barren or mineralized quartzite lithocaps are forming on shoulders of porphyry deposits. So, this is this environment of 5 different events or geologic alteration, formation events, geologic alteration. I'll discuss this afternoon, this evening. But this is our isolation for deposits, such as Kimzacocha, Salar Norte, and Pascua, deposits lying underneath steep alteration, Chicago, a low-grade dome, but on the margins, a intermediate sulfidation continuity system. Same with Levanto and Victoria veins in the Philippines, which we didn't present. We have the parole porphyry here below a bare lithocap. So a variety of possible pieces of the puzzle. And I should say, for those taking photos, these notes were given to Will. He can distribute them, or we'll upload them. And I think, yeah, just repeat. I don't know any magical. Maybe Nate has in the back pocket. He's been so successful. He's got this magic both that he's not going to tell anybody about. Even if he did have one. No tools or techniques. You have to understand your tools and techniques. Don't use black box, definitely. Otherwise, you know, jump in, jump out. If bad data is worse than no data at all, if you don't really understand what your black box is giving you. And be careful about forcing prospects into published knowledge. As I say, do as I say, not as I do. And use lateral thinking, particularly in the whole environment, along with experience, because there's a lot of lateral in epithermal environments as well as vertical. So, my apologies for taking your time and lose 10 minutes over. I'm glad to entertain any questions, if there are any. Who is the chair of this?
Well, I do have the slides, so we'll send those out on the email to anybody who's on the email list. If you're not on the email list, let me know and I'll get it to you, or I'll put it in a place where everybody can access it if you want to get it. We'll also have a recording of this lecture, and there will be a recording of the afternoon one as well. All those slides, everything's available. Just got to figure out how to disseminate it to people who don't have access to the email.
Before we go on, if there are any questions, as I said, I didn't expect Nate to be here. I'm very glad that he was. I think this is the first time you've sat through this kind of presentation, maybe specific topics, but I mean, we're old friends. I have a thick skin. The question is, have I misrepresented anything in your experience, El Indio, Salar Norte, Chicapaca, that should be corrected from the horse's mouth? Of course, there's so much detail that you could add, and you should. You should give a presentation here sometime.
Chicapaca is a good example of the thesis here. We staked all of that ground. It was open because we got up to 1 gram on surface on the zone. That's why we drove those 11 holes in 2004 and came away with 20 next. We're focused on the dome and the high sulfidation style of system up there. We knew the sedimentary rocks were around, but we didn't even think about, going underneath those sewer vessels.
You might have not had any geologists who did that, so the Moscow or what, what, Kolkahirka, thank you.
And that's why Buenaventura was.
Yeah, opened eyes, because Buenaventura was mining
And
at,
so that was a big error on my part. I'm the one who recommended farming it out rather than putting it in. And
well, we can call it an error, but it's, they're priorities, and you had a lot of other prospects, and you suddenly, for those results.
what a lesson learned.
Yeah, so as I say, at the start, we learn more from mistakes, even better if we can learn from others, the mistakes of others. We just call it a mistake, but, in 2020, hindsight, it wasn't taking it through to completion, fruition, that you could have done if you had that 2020 hindsight. But still not bad. You had
51%.
Yeah, and also then, that led into, just right around that time, then also you had Silurius Norte Colonial.
Yeah.
Yeah, good track record there.